So guys, you are watching the day one in the free Kubernetes series, Basics to Advanced. And for this series, I have put lot of efforts to prepare the content, to get the content to your plate. So guys, as much as possible, please share this video with your friends and also ask them to subscribe to the channel so that they are also learning with you. Now, in this series, primarily the focus will be on Walmart's tech stack and how in Walmart the Kubernetes was used. So from basics to architecture, to deployments, to rollouts, to production scenarios, to your database setup in Kubernetes, everything will be served to your plate. So let's get started in today's video. So guys, today we are going to learn how the architecture of the Kubernetes will be looking at, but I'll not straight go ahead with the Kubernetes infra or architecture. Now, one more important thing, there will be no slides for any of this theory videos. You have to watch the video completely till the end to understand and make notes as per your understanding. Because as I have told you, this will be completely based on the Walmart's experience, whatever I'm going to share you, right? So let's get started, guys. So before Kubernetes, let's jump on to Docker and let's understand like what exactly this Docker as a person was doing. So if you consider like Walmart, okay, www.walmart.com, when you are hitting this website, you will be able to see that there are some products which are displayed on the page, right? And when you are thinking to buy any kind of product, you are selecting that product and that product goes to the cart, right? And from the cart, once you are clicking on the cart, that product goes to the payment page. Basically, you will proceed with the payment page details, and then the product, once the payment is done, you will be seeing the order ID details, correct? So how much the user is flowing, the user journey started from here, right? And he's going to the cart journey and then the payment journey and the order journey. And once the order journey is done, what will happen? Someone will come to your address to deliver it, right? So these all things in Walmart, I was working primarily with these components. So let's consider like in today's example, we will be talking about Walmart supply chain tech. Okay. And in this Walmart supply chain tech, there is something like item and inventory. Okay. Application. When I'm talking about application, it's a application, which is maybe you can consider like a circular application file. Okay. Item and inventory, transportation. Okay. These are like microservices you can consider. Transportation, fulfillment. Okay. If you are in India, you can consider like a DMart also, and purchase order. That's how the entire supply chain journey goes with. And if you are able to see, there are 4 applications in our stack, right? Now, what happened? Just consider this journey. Okay. Now there is a Java application. Okay. This Java application was converted into a small jar file with the help of a stack called DevOps tool called Maven. And this jar file, in order to make sure this jar file is very strong, secured, robust, right, and dependency free, this jar file was placed in a container, and that container is called our Docker container, right? If you are able to see in when you are going into the kitchen, right, when your mom is working in the kitchen, you will be able to see your mom is keeping all the items in the jars or the containers to protect them, to secure them, to isolate them from other items in the kitchen. And also these containers will help to increase the shelf life of the material. In the same way, you consider this application with the help of Docker was made to place in the container. Right now you understood what is the container features, right? Same like your items. Let's say I have a sugar, right? I want to keep it in a container, right? And what are the things, right? You are making sure sugar is secure, sugar lifespan is good, right? Sugar is isolated from outside environment, sugar is protected, right? So these all things also are applicable for the containers. But guys, tell me one thing, you have one sugar jar, right? You have one sugar jar and you are trying to make sure this sugar jar is holding a capacity of 1 kg, but suddenly you had 5 kg of sugar in the home. Now what you have to do? Do you think that you will buy one single container of 1 kg jar, or you will keep a 5 kg jar sugar directly? right? It's up to you, right? So what you will decide, you tell me in the comment section whether you will go with 1 kg jar, 5 jars, or directly you will take a 5 kg jar and you will put your entire sugar into that 5 kg. That you decide. But this this makes sure like there is a scaling issue, right? You had 5 containers here and you have 1 container where you are keeping all your data or your sugar stored. Now here, if you understand, when we are trying to scale a system, we are trying to utilize the space also, correct? Let's say like the jar which is used for 5 kg container and the single jars which are utilizing the kg items, right, are utilizing some space. Correct. So the space utilization, again, their security, their protection, everything, we have to take care of that. Now, one important thing is like when the scaling happened in the containers, let's take like, I want to spin up 10 containers for a single application, right? Now, at that point of time, what happened is this Docker had to have more features in it. And that's where you will be able to see the Swarm concept of Docker. Docker Swarm is basically helping your entire Docker architecture to scale up and scale down. At the same time, this Swarm was helping the Docker containers to get managed, right? Someone has to manage, right? Suppose 5 jars are there, 5 sugar jars are there. Some person has to manage that, right? So similarly, these containers which were running in the Docker cluster or the Docker environment has to be managed by someone. Their security, their robustness, their isolation, their dependencies, everything has to be managed by someone. And due to this disadvantage, like managing a high scaled application, managing a robust application, managing an application which is taking high load of traffic was getting difficult in Docker. So that is when we had a concept which was introduced. It was nothing but, guys, Kubernetes. Now, if you see, the same concept of Docker was taken and Kubernetes was built on the platform. Now, let's imagine, okay? Let's start with imagining this Kubernetes is divided into two main components. Okay. And you can consider like one component on the left hand side, one component on the right hand side. And I bet you that this video is going to be very clean and crisp video for your understanding. Now, if you see on the left hand side, this is called your control plane or master node. Okay. And on the right hand side, if you are able to see, this is called your worker node or data plane. Okay. Now, whenever you have the Kubernetes software, the software is trying to give you two main components. One is your master node, one is your worker node. It means that you have one manager in your Kubernetes and you have one employee as of now. But you tell me, can you scale your employees? Can one manager have 2, 3 employees under him? Yes, definitely. One manager can have 2, 3 employees. Second employee I have hired. Correct. Now you tell me in the manager, right? Under the manager, there are some tasks to be done by manager. There are some tasks to be done by employees, right? So let's consider what are these tasks to be done. Now, I will be telling you simply a 4-rule theory, which I have designed for your Kubernetes to make sure that you are able to remember these topics easily. Okay. So when we are talking about the master node, there are 4 components in the master node. That is 1, 2, 3, and 4. So the first component will be your API server. The second component will be your etcd. The third component will be your control manager. And the fourth component will be your scheduler. Okay. Now, similarly, in the employee side also, there are 4 components with which this entire Kubernetes cluster is running. 1, 2, 3, and 4. The first component is called kubelet. The second component is called kubeproxy. The third component is called pod. And the fourth component is called container runtime. Very beautiful, right? I hope you are enjoying. I will make this enjoyable moment still more exciting for you. Now let's understand deeply one by one, okay, what exactly the each component is doing with respect to Kubernetes. Now let's talk about this employee part, which is our worker node. See guys, in Docker, if you have a Docker software installed, okay, now what will happen is in the Docker software, there are 10 containers and there is someone who is managing this container networks, right? This container talk, right? The networking of the Docker is managed by a component called your bridge network, your host network, and your overlay network in Docker. There are three types of networks in Docker, and the default network is the bridge network. And if you consider Docker in the same part of the Kubernetes on the worker node side, the component that is managing the entire networking of this worker node is basically your kube proxy. Okay. So in kube proxy, what will happen is this kube proxy will help in your networking component in assigning the IP address to the containers which are getting created. It will help you to understand also, it will help in load balancing functionality. Okay. And also proxy related things also it can handle and manage. So basically, if you can understand, the networking part in the worker node is managed by kube proxy. Correct? Now, if we consider in Docker, there is one important component which maintains the container states. That is your Docker shim. Okay. So what this will do is basically it will manage the entire management of the containers. Like it will take the monitoring of the containers. It will take the spin up, spin downs of the containers. It will also check the container statistics regularly. So this is kind of a controlling of the containers, right? It is controlling the container in the Docker. In the same way, you can understand this container runtime. The name itself tells, right? Under the worker node, this container runtime manages and monitors the state of containers. Very beautiful and very important, right? So whenever a container is down, up, what type of container metrics is there, state of the current container metrics, everything is done by the container runtime, right? So now let's go to the next component, that is your pod. Now let's understand, guys. I was telling you here that the transition of the Java file, Java application got converted into the jar, and then the jar was converted into a container. And with the help of Kubernetes, this container is converted into a pod. Okay. Now, this pod, if you are able to see, it is providing an extra layer of security. It's providing an extra layer of isolation. It's providing an extra layer or extra feature on top of container. And that features are nothing but, if I have to tell you, right? Okay, why it is not going? Okay, no issues. And that features, if I have to tell you, let me write it here in the separate component. Okay, by adding the new page, I will write it down, right? So this is basically, yes. So if you are able to see till here, whatever you are able to see, this is the Java app, this is the container, and on top of container, you had your pod, right? With the help of Kubernetes, you were able to convert your container into a pod. And the same way, right? In the same way, this pod is helping in security and making sure robustness, additional load balancing features it is giving you, right? And also it is trying to help you in terms of security, advanced security measures, right? It is helping you to scale up, scale down, right? and it is helping you to understand how the application is behaving. So in terms of whenever we are talking about like pod, containers, and deployments, this pod is the strongest component of Kubernetes, which holds our application very securely and very safely, right? Let's see, when I was talking about the worker node components, we have already discussed there are 4 components. I will just repeat again for your information. One was kubelet, one was container runtime, one is pod, and one is kube proxy, right? So I have told you that this kube proxy is mainly utilized for networking inside the worker node, correct? Did you got it? Container runtime monitors and checks the containers inside the worker node, correct? And the pod, I have told you, the feature by Kubernetes, okay, which is helping my application to be more robust. Correct? Don't tell the book knowledge here. What is pod means? Pod is the smallest unit of Kubernetes. What do you mean by smallest unit? Someone will ask you, yeah, what do you mean by smallest unit? Can you tell me? No. You tell by the examples that you are learning. Okay. The smallest component or the smallest feature of Kubernetes, right? Which helps in securing the application and the container in a much larger extent. That is your pod. And now let's discuss about kubelet. Now you tell me, guys, you had a manager, right? And you have your employee. There should be always a communication between your manager and your employee, correct? Do you agree with me? Right? Your manager should talk with your worker, and I mean your employee, and your employee should talk with your manager. And that's where you have a component in your worker node called kubelet. Okay. This kubelet is the primary component in your worker node which decides what to do inside the worker node. Very important. It means it is the primary factor which decides what the pod should behave. Okay, very important. So the kubelet is the primary component which decides on the worker node or takes all the data of the worker nodes and tell to the manager. Okay, now all of you see here. Yes, this is our manager. Okay, so in the manager, if you are understanding, the manager is also having 4 components according to our 4 rule theory, correct? So the first component is API server. The second component is etcd. The third component is your control manager. And the fourth component is your scheduler, correct? Right. Now all of you see here, there were 4 components, right? Again and again, I am writing for you all to just to make sure that you are understanding, right? And the only one component which is talking with your kubelet to your API server is this data flow, right? Now, if you see, the data is always two-way communication. And now, very important, what is this API server, Praveen? What is the master node components? What are the things that you are going to tell us? Very beautifully, listen carefully with me for the next 10 minutes. Now, you are a DevOps engineer. Okay, you are a DevOps engineer who is trying to work with the Kubernetes, or you are a person who is trying to hit or to manage the Kubernetes cluster. The moment you hit some command in the Kubernetes will talk with the external environments with the help of API server. API server is nothing but application programming interface server. Now, what it will do is any application in this world, you just understand like Kubernetes as a software, the front end, and there's a back end and there's a database. You can consider like that. Very sweet. Okay. Now Kubernetes is telling that, boss, if you want to talk with me, you have to first talk to the API server. Okay. If API server says yes, then you come inside the Kubernetes. If it says no, you don't come to me. You just go away from there. Okay. So the external world talk to the Kubernetes cluster is with API server. Now, the beauty here is whenever you are sending data to the Kubernetes, very beautiful concept. Whenever you are sending data to Kubernetes, the Kubernetes should store the data. Do you agree with me? Suppose Walmart supply chain application is there. Now Walmart supply chain application is taking the data. That data should be stored. Your order ID should be stored. Your order details should be stored. Your customer details should be stored. Where you are shipping the product from one place to another, it should be stored. Similarly, as your applications have database, here in Kubernetes, this is your database on the master node. The etcd full form is nothing but etc folder inside your Linux system, and D means distributed system. Okay, so it means that when the name itself tells, right, etcd, the configuration of this database is present in the master node's etc folder, and this etcd is a distributed system. What do you mean by distributed? Means whenever you are trying to create a Kubernetes cluster, this database is converted as a leader and a worker databases. So you will have multiple databases to store the data, and there will be a leader who will be listening, and I will be completely taking one session because it's a 20-day course. It's a 20-day workshop where you will be learning so many things. I'll be completely covering on the HCD, how the data is stored, what are the backup strategies of HCD, and what are the details of the HCD. We will deep dive in there. But as of now, today's video, I'll make it little crisp and sweet for your understanding, right? Now let's move forward. Once the data is stored in the format of key and value. Why key value? Because the users who are sending the data are sending the data in the key value format. Now, once the data is stored in the key value format, there should be a processor who is processing that data. And that processor is nothing but this control manager. This control manager manages or controls the entire system. It's like your brain, human brain. Okay. So in the human brain, in this control manager, there are various kinds of controllers present. One is node controller. Okay. Auto healing means your employee is not working properly. You can scale your employee, you can minus your employee, you can do the layoffs, you can do the hiring. So that's what, like, node controller, which does the hiring and firing of worker nodes by any chance or by any means. Okay, hiring and firing. Firing means if the node itself is not good, then it will remove the node and it will create a new node. Then there will be a replication controller, which takes care of the entire controlling part of your replications. Like, let's say, like, I want to have my pods anytime at a given point of time. I want to have 5 pods for my application. This is basically taken care by the control manager. Under control manager, there's a replication controller. There is a network controller, which takes care of the entire networking part on the what you call like Kubernetes cluster. And there is a CCM. It's basically a cloud control manager. This cloud control manager helps in designing the entire Kubernetes components. Basically, let's say, like, if you have any open source cloud, right? You want to integrate the Kubernetes with your own cloud, then this CCM will help in integration of all those components and configurations. Okay. So this control manager, by the name itself, you can understand it is the primary person, or you can say like head of family or your brain of human. Okay, you can call like any name. It controls the entire structured deployments, structured data of the Kubernetes. Now, all of you need to understand. Okay, let's say like here there is a pod. Okay, I will take red color here. The pod is having an issue. Immediately, with the help of container runtime, the kubelet sends the data and the kubelet tells to the API server that, okay, boss, there is an issue in the pod, you have to scale it. And this API server in turn talks with your control manager. Anyways, they all are like bi-directional talk, because whatever the data is stored in the HCD, it will read, it will process the data. And once the processing is done, let's say control manager says like, okay, boss, now this pod, we have to spin up a new pod. Okay, new pod should come in. So how do you do it? There is a component in the master node, which is scheduler. Okay, this scheduler, this control manager only tells to the scheduler, boss, what you have to do, what you have to not to do. And this scheduler will talk with your API server bidirectionally, and your API server will create a new pod in place of the wrong pod. Let's assume one more component flow here. Okay, again, I will draw for you guys, right? 1, 2, 3, 4. And here also 1, 2, 3, 4. This is API server. This is HCD. This is your control manager. And this is your scheduler. Okay. And this is your kubelet. This is your pod. This is your container runtime. And this is your, what do you call it? Other component is there, no? Kubelet, kube proxy. Okay. Kube proxy. Now let's understand this flow, guys. One person is there who is trying to deploy a pod in the Kubernetes immediately with and there is a file. Okay, obviously a file. The user is trying to deploy a application with the help of a file. That application is read by API server. The data is stored in the HCD. The control manager processes the data. It will tell to the scheduler what to do. Scheduler in turn talks with your API server. API server tells to the kubelet. Kubelet sees that, okay, boss, there is something coming to me, right? And this decision is taken by scheduler on which employee should be done what task. Let's say like I have two employees, employee 1 and employee 2. The scheduler says like, okay, employee 2 has more CPU RAM, right? Employee 2 has more CPU, RAM, memory, more kind of a strong. So it will go with the employee 2. Let's say like employee 2 is weak, cannot take the data. Then API server will go with the employee 1. That's how the scheduler will decide where the pod should go. So I hope that you have understood. Very simple, guys. If anyone asks you, you have to tell in this structure so that people on the other side feel that, guys, you have not by-hearted. You are not by-hearting or mugging up the bookish knowledge. You are only mugging up what is needed for you to survive in the market. And that's how I used to learn it. If you have liked the video on the Kubernetes architecture, we have started with just a quick recap. We have started with Docker. I have taken example of Walmart supply chain. I have told like what kind of services we have in Walmart. Then I have showed you Java jar file application conversion. Then I have told you an example of sugar container. Then I have taken you to the Kubernetes control plane, data plane, right? Master node, worker node, one manager, one employee, two employees, how the things are working, Docker networking, Docker, kube proxy, container runtime, kubelet, pod. I've told you about API server, HCD. Then I have given you so many examples like why exactly Kubernetes is more important, what exactly these guys are doing in your area. Right? I hope you have liked the video. Share this video with your friends and please subscribe to the channel. Meet you in tomorrow's video at sharp 7 p.m. Stay tuned. This series is going to be 𝐶𝐷 series for you guys. I'm bringing you everything is in my knowledge, the best capacity. I'm going to help you. Yes. If you have any doubts, you can put it in the comment section and I'll be definitely helping you. This is Singham signing off from this video. Meet you in tomorrow's video. Until then, bye.